The goal of this video is for us to master rates of change that involve the chain rule, and just recalling the chain rule from our earlier work, dy dx equals dy du times du dx is one form of the chain rule, and it happens when we got function of a function, or the composition of functions. And we've seen that before. So when there's a function of a function, we use the chain rule to find the derivative. We can see a version of that here in this problem, and we've got a glass that's in the shape of an inverted cone, and it's got height of 8 and it's got a diameter of 6. Note that if the diameter is 6, then the radius is equal to 3. So the glass's radius equals 3 centimeters for the glass. And they're pouring water in the glass at the rate of 20 centimeters cubed per second. Now we can write that as a related rate. That would be here. If V is volume, we've got dV dt. So dV dt is 20 centimeters cubed per second. At what rate is the height of the water increasing when the depth is 4? So that's the rate of change for the water. dH dt is what we've got to find. So it's important to always clarify what we have to find, and it's that. And we're given that. So let's get underway now, and if we scroll down a little bit and see the rest of the information. So always draw a diagram and denote all of your quantities and variables. Here, written information that we know is put down there. We know the volume of a cone is 1/3 pi r squared h. So it's like 1/3 of a cylinder with the same height and radius. Now we've got a number of variables there. We've got h and r and v, and that's one variable too many. So the clever thing to do is look at the actual shape that we are given. Now for the amount of water in there, it's true that it won't, the amount of water won't have a, the body of water won't have a radius of 6 and a height of 8, but it will have that ratio. So the ratio of radius to height is a constant 3/8, which is very handy, because what we can do is say r over h is 3/8, and we can say therefore r is 3/8 of h. So that means we can replace r with 3/8 of h, and so if we do that, you can see here the result, and we get 3 pi h cubed over 64. So we've only got two variables now, which suits us much better. So v versus h. So we need to find dH dt, we just said, and expressing that in terms of some of the useful items that we've got, because the terms we've got involve v and t. Because if we had a look back up here, we have dv dt, and we need to find dH dt. So if we've got dv dt and we need to find dH dt, we also need to know about dH dv. So that's the rate of change of height per unit change in the volume. So it might also pay to know that the rate at which the water height is increasing depends on its depth, and that water, as you can appreciate, when you've got like a body of water in a glass like that, the height will slow down, the height change will slow down as we go up, because it's got a larger cross section there than it does down there. Okay, so it will get slower. You've no doubt seen that before. So returning back to the problem, we've got to find dH dv. So let's have a look. You can see on the next line what they've got as a result, but let's have a closer look at that. So we had dh dt equals dh dv dv dt on this line, and how do we get dh dv by itself? Well, we've had to undo this multiplied by dv dt. So essentially that's like saying dh dt over dv dt. So we can cancel the dt's off top and bottom, and we've got dh dv, so that works. You can see that they've made a mistake here on this line. Obviously that statement there is not true, so that is meant to be a dv dh. Okay, so dv dh, and it's the inverse function, so we can get the dv dh from there. So writing that out then, to get the dv dh, it's the derivative of that with regards to h, and you get 9 pi h squared over 64 centimeters squared, and then we take that inverse of it and we get 64 over 9 pi h squared. The unit's quite interesting the way they've got it written. It's not a misprint, centimeters to the power 2. Perhaps it would make sense to call it centimeters per centimeters cubed. Whoops, centimeters per centimeters cubed, because the height is measured in centimeters and the volume is measured in centimeters cubed, and of course if you've got centimeters to the power 1 divided by centimeters cubed, your index laws tell you that you get a negative 2. But I would expect mostly we would see it as centimeters per centimeters cubed as a more rational, no pun intended, more rational type of unit. So we've got our dh dv that gets inserted in here. We always had dv dt. We multiply that together and we get 2.83 centimeters per second for our height changing per unit time. Because the substitution was made here for when the depth is equal to 4 right there, and at that point we've got 2.83 centimeters per second.